So here we are. So we did a few problems on Locus, and we'll continue with further problems on Locus. So they are Locus directly Locus problems based on coordinate systems, and then the Locus problems based on parametric representation. So we will do both. Okay, so let us do this. A point moves such that the sum of its distances from two fixed points a comma ae comma 0 and minus ae comma 0 is always 2a. Prove that the equation of the locus is this. So we covered one. I'll mark this as problem number 2. A point moves such that the sum of its distances from two fixed points ae comma 0 and minus ae comma 0 is always equal to 2a. Prove that the equation of the locus is this. So let the two fixed points be A, ae comma 0 and B, minus ae comma 0. Now, let P, h comma k be the point for which the equation of the locus, or it's the equation of its locus, is to be found. So let P, h comma k be the point for which the equation of its locus is to be found. So given condition is PA plus PB is equal to 2A. So we have PA under root of x minus AE the whole square plus y minus 0 the whole square plus under root of x minus of minus AE, that is x plus AE the whole square plus y minus 0 the whole square is equal to 2a. Now, how to solve this? Now, we can square on both sides directly, but when we square this in this form directly, let this be a, let this be b. So a plus b the whole square, we get a square plus b square plus 2ab. So twice of this under root and this under root. So under root again with a complicated multiplication will be there. So better to do like this. Keep this term and shift this term to the right side. Now square on both sides. This becomes easier. If we square on both sides, we get x minus ae the whole square plus y square is equal to 4a square plus x plus ae the whole square plus y square minus 2 into 2a 4a under root of x plus ae the whole square plus y square. So what you get is y square cancels. This further cancels. X square plus ae square, x square plus ae square also gets cancelled. We are left with minus 2ae this side plus 4a square minus 4a I have simplified. I have eliminated. I have simplified one step. I have skipped. I write this as x square minus 2ae plus a square e square. And here also x square plus 2ae. So we have plus 2ae here, plus 2ae. Okay. So I bring this negative side term to the left. I get 4a into under root of x plus ae the whole square plus 4y square and 4a square plus 4ae. So if I take 4a common, I get a plus e. So what happens is 4a and 4a on this side gets cancelled. Now squaring, again squaring on both sides. This is 2aex, I'm sorry, 2aex here. So here also it is 2 minus 2aex, 4aex, so ex. I have ex here. Squaring again on both sides. We get x plus ae the whole square plus y square equal to a plus ex the whole square. So when we expand, we get x square plus 2aex plus a square e square plus y square is equal to a square plus 2aex plus e square x square. So again, this 2aex and 2aex cancel. We are left with, bring this to this side, x square minus e square x square plus y square I retain here, and I take this a square e square to the other side. So I get x square upon 1 minus e square plus y square is equal to a square minus of 1 minus e square. A square into 1 minus E square. A square into 1 minus E square. Now I want in which form? This form. So, so right side is 1. So dividing by A square into 1 minus E square throughout. So what do you get? X square into 1 minus E square upon A square into 1 minus E square. So we get X square upon A square plus Y square upon A square into 1 minus E square equal to 1. All right. So this is the result. So we found that this is the equation to the locus. What did we do? This was the only step we applied the condition and we brought it to here. After that, it is all just algebraic simplification. It is just manipulation for which we need practice. Concept wise, our concept ended here. Now we had to move this and do squaring on both sides, cancelling terms, again squaring on both sides, cancelling terms, and just manipulating the result to get into this. Okay, that is one equation. Next question. This is a objective type question. What is the nature of the locus represented by this equation? Now this is the equation. X minus y plus c whole square plus y plus y, x plus y minus c the whole square is equal to 0. So can any one of you say how to do this? Locus equation is already given. Now, what is the nature of this locus? Is it a circle? Is it a straight line? Is it, what curve can we call this? How would you do? How would you approach this problem? Any ideas? Think. What are all the points that will satisfy this equation? Yes, no. Any idea? None of you is answering?
No, sir.
Okay. Chaitra?
No, sir.
So just look at this. Suppose A plus B is 0. What does it mean? Suppose A plus B is 0, then B will be a negative value of A, correct?
Yes.
In general. In general, this is what our conclusion is. However, here if we see, this is a square and this is also a square. And in between, there is a plus sign. There is no minus sign. Okay. So sum of two positive numbers is equal to 0 will imply, so a plus b equal to 0 can also be 0 if a equal to 0 and b equal to 0. Understand? Na? So what it implies is, this is very important. There's the trick in this question. The sum of two squares is 0. That means sum of two positive numbers is 0, implies that each term is 0. So each term is equal to 0. So each term equal to 0, x minus y plus c equal to 0, and x plus y minus c equal to 0. So this means this is the first and this is the second. Now both should be simultaneously 0. Okay, both must simultaneously be 0. So both are simultaneously 0. So which are the values of x and y that will satisfy this equation? That we have to see. So we'll solve for x and y. Solve 1 and 2 for x and y. So when you add 1 plus 2, this will give x plus x 2x plus 0 plus 0. 2x minus y plus y is 0 plus c minus c is 0 is equal to 0, which implies x equal to 0. All right. Now substitute x equal to 0 in either 1 or 2. Okay. Substituting into we get 0 plus y minus c equal to 0, which means y is equal to c. Therefore, only one point x comma y is equal to 0 comma c satisfies the above equation. Therefore, the locus so the locus represented by the given equation is a point. Is a point. So only one point satisfies this equation, that is 0 comma c. So locus generally represents a set of all the points which follows a path which satisfies a given equation. So So this represents a point. So this is a very important objective question. And from IIT JEE point of view, this kind of question is very important. Okay, there are many other important questions. Each time I see a question, I cannot skip it. In coordinate geometry, this problem of locus is a very, very important problem. So generally all in coordinate geometry, problems based on locus is very, very important. So it is important for us to do problems on locus thoroughly. So now next question, the coordinates of 3 points O, A, B, O 0, 0, A 0, 4, B 6, 0 respectively. A point P moves so that the area of triangle POA is always twice the area of triangle POB. Find the equation of both the parts of the locus. So this is just the area of the triangle problem. Zero, 0, this is O. A is 0, 4, 1, 2, 3, 4, let's say. And B 6, 0, 1, 2, 3, 4, 5, 6. O A B. So 0, 0, 4, 0, 4, 6, 0. Now a point moves such that, let's say any point, this is P, H, K. Now, this point P is such that the area formed by triangle OAP, OAP, this triangle area is double that of this triangle. Of course, the figure doesn't reflect it because we are randomly putting it. But let us say, so this is A1, this is A2. So A1 is twice of A2. So it is given that area of triangle OAP is equal to area of triangle OBP is twice of O area of triangle OBP. Okay. POA or OAP is same as OBP. So this is the area of the triangle. So now how to calculate the area of the triangle? We know from coordinate geometry. So first write down the points. It will be easier. Of course, the points are here. You can see this. So half times, we will do the cross multiplication method. Half modulus of O, coordinates of O 0, 0, coordinates of A 0, 4, coordinates of P H, K, and again coordinates of 0, coordinates of O. We write like this. Then twice of half O, coordinates of O, then coordinates of B 6, 0, and coordinates of P H, K, and again 0, 0. So now both sides is modulus. So now we do the cross multiplication. This multiplied by product of this minus product of this, product of this minus product of this, product of this minus product of this. So what we get is half modulus of 0 minus 0 plus 0 minus 4h plus 0 minus 0. Okay. Next, this is equal to 1 times. Again, do the same cross multiplication. This product minus this product minus this product, this minus this. So we get 1 times 0 minus 0 plus 6k minus 0 plus 0 minus 0. So what we get is half of modulus of minus 4h, which is modulus of 4h, and here we get 6k. So of course 4 can come out, and modulus of minus 1 is 1. So we can write this as 2 times mod h is equal to 6 times mod k, which implies mod h is equal to 3 mod k. So now replace h by x and k by y. So we get mod x is equal to 3 mod y. Now, depending on the sign, you will get two cases. Either, both sides positive or both sides negative, or one side positive, one side negative. So x will be either plus 3y or x equal to minus 3y. So these are the equations to the locus. Okay, these two are the equations to the locus. Clear?
Yes, sir.
And that's the answer, x equal to plus or minus 3y. All right. I'll ask you to do these other problems. This problem I do, it is an important one. Question 5. A rod of length A slides along the x-axis. That means it is the whole rod is moving along the x-axis, and another rod of length B slides along the y-axis such that their ends are concyclic. A rod of length A slides along the x-axis and another rod of length B slides along the y-axis such that their ends are concyclic. What do you mean? What do we mean by concyclic? What do we mean by concyclic? Anyone?
No idea, sir.
How about you, Chaitra? Are you there?
Yes, sir.
Hmm. What do you mean by concyclic?
No idea, sir.
Concyclic means they lie on the same circle. So concyclic points are those points which lie on the same circle. Okay. So the ends of the rods are concyclic. So let us draw a circle. Hmm. So it is moving like this. All right. So there is this rod here, a rod of length A slides along the x-axis. So this actually, first we have to draw the rod and then the circle, but we are doing the opposite. First we are drawing the circle. And then, so this is the first rod. Of length A. Okay. And this is the second rod of length B. So think of these rods like a hollow pipes. And these pipes are placed within the hollow pipes are placed within these rods, x-axis and y-axis, and they are moving. When they are moving, they move in such a way that these 4 points, the ends of these rods are concyclic. The point A, B, C, D. These are 4 points. The lengths of the rods are small a and small b. So these ends are concyclic. A, B, C, D. They are lying on the same circle. Now, what do we want to find? So first, getting the figure right itself is a big challenge. Once you get the figure right, after that, find the locus of the center of the circle. So we are looking for the locus of what? Center of this circle. So whichever point we need to find the locus for, first step, what we should do is write that point as P, H, comma, K. That is the first and foremost step that we should do. Okay. So the circle through the ends of the rod is as shown in the figure. Correct? Now, if this is shown in the figure like this, now we want the locus of the center of the circle. Let the center of the circle be P, H, comma, K. P, H, comma, K. Now, this is a circle of variable radius. Why? Because as the rods move away, then the circle will go bigger. Okay. So it's a circle of variable radius. But at any given point, this will be the figure. Now what happens? Now what happens is you drop perpendicular from P onto AB and from P onto CD. Okay. From P onto AB and P onto CD. Now this is H comma K. All right. This height is K because this height, this is x-axis, right? This is x-axis. So distance of the point P from the x-axis will be its y coordinate, K. All right. And distance of P from the y-axis will be H. This is H. You move H distance along X, Y distance along, K distance along Y to get H comma K. So this is H. All right. Now what to do? This length here will be A by 2. This length here will be A by 2. Why? Very important property in circles. Okay, the radial line or the line, the perpendicular line to from the circle to the chord of a circle bisects the chord into two equal halves. This is a theorem that is there in geometry, well-known theorem. So here, this is again a perpendicular drawn to the chord, and this divides the chord into two equal halves, B by 2, B by 2. Okay. Now what I do, I have H as one side, B by 2 as other side, and I have this radial line This will be the radius r. Similarly, I have this radial line as the radius r. Okay. So let us, see the things that I've drawn. It is not so easy to conceive, at least for the first time practice. After a few times, when you keep practicing, this will seem easy for you, but first time this problem will seem very tricky. So from P, I drop perpendiculars. Ouch. I drop perpendiculars M and N. Okay. So from P, let there be perpendiculars PM on rod AB and PN on rod CD. Now M bisects AB and N bisects CD. All right. Now from triangles APM, this is a right angle triangle with R as the radius. We get, because it's a right angle triangle, AP square is equal to PM square plus AM square. So we get AP square is R square, PM square is K square, plus AM square is A by 2, the whole square. So this is the first equation. R square is equal to K square plus A square by 2. Next, from triangle, next triangle, APM, now we have CPN. CPN, we get. So CP square is equal to PN square plus CN square. CP square, the hypotenuse, is PN square plus CN square. So from here we get, just a sec. Just okay. So this is R square is equal to, what is PN square H square plus CN square is B by 2, the whole square, because it bisects. Okay. Now R is variable for any circle, but for any given circle, R will be same. So radius is same. If the circle expands, R will change. But for the same circle, this PC will be equal to PA, which is equal to radius. So from 1 and 2, from 1 and 2, R square is this. So K square plus A square by 4 is equal to h square plus b square by 4, because equating r squares. This is r square, this is r square. So both will be equal. So from here we get a square by 4 minus b square by 4 is equal to h square minus k square. Look at the solution. Okay, multiply by 4 all sides. So you get a square minus b square is equal to 4 times h square minus k square. Therefore, now replacing h by x and k by y, we get, so 4 times x square minus y square is equal to a square minus b square. All right, this is not a standard textbook problem, but it is a common logical problem that you often get in JEE type preparation. We cannot guarantee that in JEE you will get exactly like this, but something similar. So this is a very important problem to practice. Okay, very important problem to practice. All right, so I'll stop the class here today. All right, you can go through. I'll share the notes. You can go through this and practice whatever I've just did in class. You just practice, and then in addition, you can do the homework practice problems. Are there any questions?